Yeah, let's begin. So, whenever we're talking about uh, limits of accuracy, it's also called bounds. Student, just write it down. Bounds. So, bounds is basically the topic where you talk about the extent of a number being accurate. So, we think about the fact that how close can something be to an accurate value, to an actual value, right? So, in bounds, we study the extent of it, but not to extent themselves.
Mhm.
There are two
Yeah.
types of bounds. There is the upper bound, and then there is a lower bound. Okay.
Okay.
Now, upper bound and lower bound can be calculated in two specific but very easy manner. So, for example, if I always just give example to my student. For example, if you was asked about the distance between, let's say, Lahore and Islamabad is roughly 400 kilometers, right?
Mm-hmm.
And let's say the traveling time travel, taken to travel is roughly somewhere around 4 hours, right? So, logically speaking, the best way to do it is simply just dividing that. Okay, 400 kilometers in 4 hours, right? So it means that the speed should be 100 kilometer per hour. So this is roughly the exact value. But what if we wanted to calculate the hours, or what if we wanted to calculate the upper and lower bound of the distance or the speed, or for example the time taken? There are a few methods to it. First things first. You know what is the formula which relates speed, distance, and time?
Speed, distance, and time.
Yes.
Speed equals to distance over time.
Okay. So the question says find the upper bound and lower bounds of speed. You know that speed equals distance divided by the time taken. Okay. The distance
Mm-hmm.
is of 400 kilometers and the time taken is of 4 hours. So doesn't that become 100 kilometer per hour?
Yeah,
This
it
is the
does.
average speed, right? Okay. Now there is a formula that I wanted to tell you, and I tell this formula to each and every student. And that formula is, yeah, I started the recording as well. That formula is um, error equals accuracy divided by 2. Look, when I explained what bounds is, I told you that it is the extent of a number being accurate, right? So
Yep.
the extent of the distance being accurate is 400. The margin of error that you need here is supposed to be what? If let's say if I told you that it is 400 kilometers, and let me just add another bit of information to it so that this makes more sense. 400 kilometers nearest to 10 kilometers, and the time taken to travel is 4 hours uh, nearest to 1 hour, right? So this is just one thing that I had wanted to add.
Okay.
What does this do? Just write it down. What this actually does is that this 10 nearest to 10 kilometers and nearest to 1 hour shows the extent to which this is accurate. Okay, so this is showing the extent to which this is accurate. Now, for example, 400 kilometers nearest to 10 kilometers can also mean that the distance is roughly 396 kilometers, or it can be 403 kilometers. It doesn't have to be exactly 400, right? 4 hours doesn't have to be exactly 4 hours on the dot. It can be 3 hours and 57 minutes as well, right? And it can also be 4 hours and 5 minutes as well, right? So what does this do? This tells us the extent of activity. In order to find the error in it, we divide the value by 2. So if you want to find the error of distance, that becomes 10 over 2, which is 5 kilometers, isn't it?
Yep.
And if you want to find the error of time, how much does that become? 1 over 2. 1 over 2 hours is basically 30 minutes. So
Hmm.
1 over 2 becomes 0.5 hours. Now what I want you to do, I want you to take the upper bound and lower bound of distance and time first. Forget about the speed. The question is
Hmm.
find the upper bound and lower bound of speed, but for now forget about it. Find the upper bound and lower bound of the distance first. Now, distance is of 400 and the upper bound is going to be plus 5 and the lower bound is going to be minus 5. So this becomes 405 and this becomes 395, isn't it?
Yep.
Okay. Time. Time is of 4 hours and the error is of 0.5 hours. So maximum upper bound of time becomes 4.5 hours and the lower bound of time becomes 3.5 hours. Do we agree with all of that is being said as of now?
Yep.
Okay. Now be careful. First write all of this down and then tell me. Chalo.
Okay. Okay, I've written it down.
Okay. So now be careful. You are told to find the upper bound and lower bound of speed. Now let's focus on speed. Let me rewrite the formula. Speed equals distance divided by time. Now think about this very, very logically. Look, here we have a fraction, right? Here we have a fraction. If I want to find upper bound of speed, I want you to represent a few arrows. Upper bound of speed means that I should consider the upper bound of distance and the lower bound of time, isn't it?
Yep.
Because if I'm considering the lower bound of time, and we know that time is in fact the denominator, so what happens is that we are going to get the desired amount for speed, isn't it?
Yep.
Yes. So the upper bound of distance was 405
Yep.
and the lower bound of time was 3.5 hours. So if you were to calculate on your calculator, what answer would you exactly get?
So that would be 5 divided by 3.5.
405 divided by 3.5.
That would be 115.714.
115. Okay. What does 115.7 represent? It represents the maximum possible speed.
Okay.
Maximum possible speed or average speed per hour. Do you understand this concept now?
Yep.
Okay. Now let's talk about the lower bound of speed. Write the formula. Speed equals, let me use a different colored pen. Let's just use the red one. Speed equals distance over time. Okay, I want to find, in this case, the lower bound of speed. For whatever final value I want to find the lower bound of, I will consider the same thing for the numerator and the opposite for the denominator. Now tell me, what is the lower bound of the distance?
So then that means, hmm. So then the entire thing, meaning by, would we have to subtract 5 from 400 and, ugh, what?
Yeah,
Hold on. Yeah, okay.
we've already
400.
done it. Now we've already done it before.
Yeah, yeah, yeah. So it would be 395
Okay,
divided by, would 3.5 be the same?
think again. We need the upper bound of time.
Oh, okay, okay. So then that means we'd have to add zero point 0.5.
Yes. So what does that become?
That would be 4.
Vanya, it looks like you're not attentive in class. We're, we're, we've already taken the upper bound and lower bound of time before.
I'm sorry.
Yeah, so we have to take the upper bound of time, and we've already taken it before. It's 4.5. 4 was the original value, right? It was the accuracy, it was the degree of accuracy. Okay,
Okay.
that's why I told you to perform all of these steps before. Perform these steps, then attempt the question, right?
Right, okay, okay.
4.5 will be the denominator. Can you calculate it and tell me what answer do you get?
Mm-hmm. 8.7. Wait, no, 87.7 reoccurring.
87.7. So 87.7. Okay. What does this show us? It shows us the minimum possible average speed per hour. So now do you understand the difference between the upper and lower bounds in this case?
Yeah, I do. Just give me a moment. I want to look at whatever I wrote down first.
Okay, okay, sure. Take your time.
Maybe I could do that after
No, no,
class.
just do it right now because this concept is really important. Take your time and think
Okay.
about it. If there's any question, ask. Ask me
Okay,
questions. Not
okay.
an issue.
Just give me 3 minutes,
Yeah,
please.
sure, no problem.
Okay, yes, I understand.
Okay. You didn't need the 3 minute break. You understand, right?
No, no. Yeah, I just looked through it quickly. I found out where I got confused.
Okay. Now let's solve a few examples of this. Okay, I might have to extend your class for 10 to 15 minutes more. Okay.
Yeah, that's okay. That's completely on me.
So, for example, if there was a mass of a box, this is a question, by the way. Mass of
I'll
a
solve this
box.
one myself.
I'm sure you can try it out. Mass of a box is, let's say, 20 kilograms to nearest 2 kg. And let's say the mass of its packing. In fact, you shouldn't solve this one yourself because here it's a different formula.
Hmm.
So I'll
Okay,
let you
okay.
solve it, okay? Mass of its packing inside, whatever is packed inside of it, or whatever product it could be, is 2 kg. Uh, to nearest, let's say, let's make it difficult, 1/10 of a kg. Write the question down. I'm coming in a minute. Yes. Are you done writing?
Yep.
Okay. Now, I the first things first. I want you to make 4 lines of equation. You know that error equals accuracy divided by 2, right?
Yep.
So the first error that accuracy that has been given to you is nearest to 2 kilogram, and the second one is nearest to 1/10 of 2 kilogram.
Okay.
Now be very careful. Let's say you want to find the error of extent of the box. Let's say error of depth. That's simply
Okay.
2 divided by 2, which becomes 1 kilogram, right?
Yep.
That's for the box. What about the packing which is inside of it?
I don't know whether this is correct or not, but I just divided 1 with 10 and then I got zero point 0.1 and then I divided zero point 0.1 with 2, so then I got
Good job. Very well
0.05.
done.
Okay.
So that's error of a packing. Look, 1 kg is 1 kg, right? And 1/10 of a kg is 0.1 kilogram. And if you wanted to find the value of its error, you have to divide that by 2. So you get 0.1 divided by 2, which becomes 0.05 kilogram.
Yep.
Is it? Acha.
I understand.
So this is the first part, but we're not done with it exactly. We're not even done with half of the question. If I told you find the upper bound of box and the lower bound of box without the packing layers,
Okay.
so that becomes 20 plus 1 and 20 minus 1. Am I right or am I wrong?
You're right.
Okay. So this becomes 21 kilogram and that becomes 19 kilogram, right? Okay.
Yeah.
And if I told you to find the upper bound and the lower bound of its packing, which is inside of it,
So that means,
so the initial value that we have is of 2 kilogram, right?
yeah.
So this becomes 2 plus 0.05
Okay.
and lower bound becomes 2 minus 0.05. Are we correct?
Yep.
So this might become 2.05 and 2 minus, sorry, this might become, can you solve 2 minus 0.05 on your calculator? It must be 1.95, I believe.
Mm-hmm.
So just solve it and verify it.
2 minus 0.05.
Yeah,
1.95.
1.95. Great job. This is where we are done with half of the question.
Yeah, because I think we have to integrate a formula. Like,
Exactly. Now, what is the formula? The question says, now look, focus on the question. Find the upper bound of total mass of the box and its packing. Okay. How how do you make a formula? Making a formula is very easy. Most of the time, it's just logic. Look, the
Hmm.
total mass is supposed to be the mass which is inside the box, which is like basically the mass of packing, and the mass of what do you call it? The box, right?
Okay.
So that's supposed to be the total mass that you need, right? Now, considering the fact that we want to find the upper bound, here we don't have any sort of a division sign, right? Both of
Yeah.
them are plus signs. So if we want to find the maximum possible value, which is the upper bound, so both of them we'll be taking upper bounds of each other, right? Mass of the packing and mass of the box.
Okay. So then, all right. I understand.
Okay. So in this case, what are we going to have? The upper bound of the mass of packing, which is basically simply 4.05,
And the mass of and
upper
the
bound of the
box
mass
thing.
of box, which is going to be 21, right? So
Yeah.
what do? We just add them both together.
Yeah. And if you add them both together, you get 23.05. And you
Exactly.
divide this number with two.
No, why do you have to divide it by 2?
I don't know. I just kind of got confused on this
No, no, no.
part.
This is the upper bound, right? So you don't divide bounds by 2. No, the
Oh.
only thing that you
Okay.
divide by 2 is the accuracy, and the
All right.
accuracy is always given in the question. Like here, it was given in the question, right?
Yeah.
Um,
Yeah.
so yeah. Now think about this logically. If you were to find, let's say, the lower bound of the total mass. This is another question, and it says find the lower bound of total mass.
So then that just means you add 19 and 1.95.
19 and 1.95. Yes, that would be the correct approach. So look,
20.95.
total mass means the lower bound of mass of packing, which is inside the box or whatever product it could be. And if you were to add that value to the mass of the box, or uska bhi you're going to take the lower bound. Okay. So that becomes
Okay.
19 plus 1.95.
All
So
right.
I think that becomes 20.95 if I'm not wrong.
Yeah, I checked it on a calculator. It's 20.95.
Yes. So this genuinely the topic of bounds. You wouldn't find any other question apart from these two are much easier because bounds is not a very detailed topic in itself.
Yeah, okay.
In next class, inshallah.